Welcome to the Law of Conservation of Momentum problem solving part. Let's review. Law of conservation of momentum states that the total momentum of two objects before collision is equal to the total momentum of two objects after collision. Mathematically, it expressed by this formula. So we have here momentum, the total momentum before the collision is equal to the total momentum of after collision. Okay. Now I will not go deeper into the concept of the law of conservation of momentum. We have 3 videos saved in your flash drive and in your LMS for you to watch. So if you haven't watched the videos, please watch it now before you proceed to this problem solving part. So we have first problem here. We have two cards, a red card and a blue card with the same mass. That's 0.500 kilogram. Now, before the collision, the red card has a velocity of 3 meters per second, while the blue card is at rest. And after the collision, the red card stops and the blue card moves. Okay. This is an example of an elastic collision. Now the question would be, what is the velocity of the blue card after the collision? These are the choices for problem number 1. In order to solve this problem, first you have to draw a diagram just like this. Then create a table like this with the corresponding given and the variables being asked. So for mass number 1, we'll have 1 as red, okay, 1 as red, and 2 as blue. So M1, meaning mass of red card, that would be 0.500 kilogram, and the velocity of the red card before the collision, that's 3 meters per second. And then for M2, that's for blue card, mass of blue card, that's the same, 0.500 kilogram, and it is at rest, so therefore its velocity is 0 meter per second. And then after the collision, this will be now their velocity and their masses. So the same mass for M1 and M2, but for their velocity, from 3 meter per second, it becomes now 0 meter per second. And then these will be the variables being asked. What would be the velocity of the blue card after the collision? Okay. So again, don't confuse. 1 here is for all variables for 1. That will be for red card. And all variables for 2. That will be for blue card. So we are done finding the given and the one being asked. So let's start with formula here. So we have the formula for the law of conservation of momentum. We have this, the total momentum before the collision is equal to the total momentum after the collision. So we have to break this one. We all know that momentum can be the result of the product between mass and velocity. So that's why we have m1 v1 here for momentum 1 and m2 v2 here for momentum 2. Now, if you notice, we have this symbol here. We're gonna call this one prime. We use prime in order to distinguish from one variable to another variable. In this case, we have one momentum for number 1 and another momentum for this one. So In order to distinguish from this into this, we have to put prime. And if the variable has prime, it means after the collision. So I hope that is clear. So pure substitution, we have this for M1, we have this one for M2 and V2. So just pure substitution. So that is why it is so important that you know your given and you know what's being asked. Because without this, you cannot proceed to the next step. Okay. Then we have 0.500 kilogram meter times 3 meter per second. And the result would be this. And then you multiply this number here. The result will be 0. A number multiplied by 0 is 0. Same thing with this. And here. Okay, you just simply copy. Simplify. So you will have this one. So cancel, cancel because it's 0. So we have this 1.5 kilogram meter per second is okay is equal to 0.500 kilogram multiplied by the velocity of the blue cart after the collision. So simplify, get rid of this number so that we will know the value of the V2 prime. So divide both sides by 0.500 kilogram. Then cancel. Okay, let me simplify, cancel, and then cancel this one, cancel. So the remaining unit that will be meter per second, and you have this number here. Okay. So in the given choices, the answer is letter B. Okay. Let's proceed to the second problem. This is example number 2, perfectly inelastic collision. Lola Remedios, with a mass of 80 kilogram, whizzes around the rink with a velocity of 6 meter per second. She suddenly collides with Roberto, with a mass of 40 kilogram, who is at rest directly in her path. Rather than knock him over, she picks him up and continues in motion without braking. Determine the velocity of Lola Remedios and Roberto. So again, in solving physics problem, you have to draw a diagram. So this is before the collision and after the collision. Okay. So we have this number here. So the mass of Lola Remedios, that's 80 kilogram, and the mass of Roberto, that's 40 kilogram. The velocity of Lola Remedios is 6 meter per second, while Roberto is at rest. And then look, okay, especially observe the velocity. So why is it only 1? Because Lola Remedios pick up Roberto, and whatever the velocity of Lola Remedios now would also be the velocity of Roberto. That's why they do have the same velocity. And these are the given. So next would be create this table here just like this and then put all the given. Again, let me highlight all number 1 variables is for Lola Remedios, and all number 2 variables that would be for Roberto. After this, then you get the formula here. Okay, you might be asking, why is it not M1 V1 prime plus M2 V2 prime? Why is the formulas being changed? Okay. So it is because they do have now the same velocity after the collision. That's why we combine the mass and then multiply it with their velocity as 1. Okay. So let's simplify here. Okay. We have the mass of Lola Remedios and its velocity before the collision. Mass of Roberto with his velocity before the collision, and then look at the illustration or the diagram here, like on your left side. Okay, their mass is combined, and they have the same velocity. We only have one velocity here, so that's why we have this formula here. So simplify. We have here 80 times 60, that's 480 kilogram meter per second. 40 times 0, that's 0. And then 80 plus 40 kilogram, that's 120 kilogram. And then you simplify. So you want to have the value of the velocity, the combined velocity. So we have it here. Okay, in order to get rid of this number, we have to divide it by 120 kilogram both sides. And we remain with this unit here. Okay, then 480 divided by 120, that's 4 meters per second, and you get the value here. So their combined velocity after the collision is 4 meter per second. So the answer would be letter C. Now let's go to inelastic collision. Here's an example of inelastic collision. Now, a 1,000 kilogram car was paused at a stop sign when a 300 kilogram truck rammed into it from behind going 20 meters per second. If the truck continues forward at 10 meters per second after the contact, what is the resulting velocity of the car? So these are the choices. Okay. Again, first is you have to draw this table and then you put all the given. So we have M1, let all 1 be for the car. Okay. So for the car, it has a mass of 1,000 kilogram, and then it has a velocity of 0 meter per second. You might be asking, why is it 0 meter per second? It's because it was paused at a stop sign, so it's at rest. Okay. Next would be the mass number 2 and all variables with 2's as a subscript. That would be for truck. Okay, that would be for truck. It has a mass of 3,000 kilogram and a velocity of 20 meter per second. Okay. Now, after the collision, okay, the car still has 1,000 kilogram, and then this is what being asked. What would be its resulting velocity? Okay, and then we have here for the truck, that's 3,000 kilogram. This is the same mass before the collision. But from 20 meter per second before the collision, it has now 10 meter per second after the collision. Okay, so its velocity was changed. Okay, so the same, you get the formula. Okay, and then you do the substitutions for M1 for the mass of car, that's 1,000. Then V1 here, you get this from here, that's 0 meter per second. M2 for V2, M1, then V1 prime, M2, and V2 prime. Okay, then you simplify. So you have here 1,000 multiplied by 0 is 0, then 3,000 times 20, that's 60 kilogram meter per second, then 1,000 kilogram multiplied by V1 prime, you just simply copy, can't do anything about it. Then 3,000 kilogram times 10 meter per second, and you get this value here, 30,000 kilogram meter per second. Then simplify and you get this number. So here, the 30,000 kilogram meter per second is being transferred to the other part. so that you'll get this number here, and it's easier for you to simplify. What remains in the other side is this one, the 1000 kilogram V1 prime. Okay, and then you simplify this, you get this number. Okay, and how to get the value of the V1 prime? So you get rid of this number here. So how? So you divide both sides by 1000 kilogram, then cancel, then cancel, then cancel. I mean, yeah, this one as a result, you have the same uh, unit, which is meter per second, and then 30,000 divided by 1000, that's 30, and then you get this final answer, which is 30 meter per second. This is the value now of the velocity of the car after the collision. So the answer would be letter D. Okay, that's all for the law of conservation of momentum problem solving. Now, if you do have some questions or concerns, just please don't hesitate to contact me. I'm always available in Messenger or you can email me. But I would really suggest you contact me in Facebook Messenger because in that way I could respond faster. So that's all. Goodbye and thank you for listening.